The final consists of these things. So as I said before, literally the first 6 things I have to give. 7 through 9 all cover a concept about the difference quotient. I've given more than one only because I think we need to practice it, but there's only going to be one that you'll see. And then 10 and 11 are also on there. And then I just said, yo, you should know how to solve a triangle as much as I talked about it. So that's the only ones that I've decided to add to your final. Across the board, my colleagues are making, I'm sure, 20 problem finals. I just said, let's just end this thing, okay? All right, so 10, yeah, roughly. So what are we talking about? So 1 through 6, then 7, 8, and 9 are all one problem. So that's 7, 8, 9, 10. Yeah, that's going to be 10. Yeah. 10 points a problem. Sorry, 20 points a problem out of 200 points. The final's worth 200. Right? All right, we'll start with number 1. This is roughly reviewed. The ID is also here. You can go into study plan, right? If you click study plan, go into chapter 5, section 5, problem 61. You can practice this as much as you like. All right, you'll be given a graph and you'll be asked to find the period and the amplitude. I know we've done this before, but let's go ahead and refresh. So we're talking about, let's get all the way down here. So when we have A, the sine of bx, or A, the cosine of bx. It's going to be one of those two things. And so the way that you know is that the sine goes to the origin, and the cosine goes through the y-axis somewhere else. Okay. And therefore, what is this one going to be? Cosine. This one's cosine, right? Because it goes through, it doesn't go through the origin. Okay. The period, so the period and the amplitude for both of these are exactly the same. The amplitude is simply the absolute value of the number in front, and the period is 2 pi over b. Yes?
Would this be posted?
Yes, yes, I'm going to put this. We're recording now, and it's going up there. We'll need a name for it. What should we name this? It's just final exam review. The problem is I probably will put pre-calc in it. So let's just agree we're going to name it final exam review pre-calc. Right, and again, if you type in that with my name, then it should come up. Okay, so the period is 2 pi over b. Okay, so here you're going to be given the graph, and all you're doing is looking for how often this repeats. Okay, what's the amplitude?
2. -2.
The amplitude is 2. Is that okay? And the period, how often does this repeat? Start wherever you like and just see how long it takes to get back to the same place. What's the period? 4 pi. Questions? The period is the length of the interval it takes for the graph to start repeating itself. Is that okay? So now let's find out what b is. So the period is, so the period from the picture is 4 pi, but the formula for the period is 2 pi over b. So 2 pi over b is equal to 4 pi, and we need to solve for b. B is 1/2. So flipping both sides, b over 2 pi is equal to 1 over 4 pi. And then we'll multiply both sides by 2 pi. B is 2 pi over 4 pi. B is 1/2. Okay. From what I recall, I think they just ask you for the period and the amplitude. Let's look it up. Questions about that?
Is the problem going to look like that though? Like how
It is not.
Okay.
So they're going to give you the picture,
Right.
and then they're going to say this function represents. They're going to tell some story, and then they're going to ask what's the period and what's the amplitude.
Okay, so it won't say like the y equal.
No, it won't.
Okay.
Yeah, it's going to give you the picture, tell some story about what that function represents, some wave frequency thing, and then it's going to say, tell me what the period and amplitude of that is. Yeah.
So we don't need to solve for the y.
No, you won't. Yeah, it won't even ask you that function, I don't believe. But I'll double check. That's number one. Questions on number one?
Amplitude is 2 because.
It's the highest and lowest it goes.
Okay.
The amplitude is the farthest distance from rest. So when you hear no sound, and then I start talking, right, the amplitude is how far up, how loud I got, right? Yes?
So how would you write the answer?
Oh, so the question is going to ask for the period and the amplitude. So there'll be a space for period, and then you'll put 4 pi, and then there'll be a space for amplitude. I think they ask it in the opposite order, and then you'll just put 2. Yeah. Triangle. Draw this picture. It won't be multiple choice, but this is the closest one in my math lab to this type of problem. Yeah, so. This has to do with a right triangle. Draw this right triangle. You'll need to bring your calculator. This is one of the problems where you'll need a calculator. There's another one where they'll want you to graph a function with your calculator. So we'll have to talk about that. A building 280 feet tall casts a 70-foot shadow. If a person stands at the end of the shadow and looks up to the top of the building, what is the angle of the person's eyes to the top of the building to the nearest 100th of a degree? Assume the person's eyes are 6 feet above ground level. Picture? Got that, right? Cast a shadow like that, right? Some person standing here, right? Is that okay? To the top of the building, right? So we're looking for this angle. Is that okay? That's of course the same as this angle, right? Is that okay? So you're looking for this angle, and so how would we do this? What do we know? What's this distance?
280.
This is 280. What is this? 70. That's the shadow. And what are we looking for? This angle? What angle relates those three things? What trig function? This angle, the opposite and the adjacent, tangent. Tangent of theta is opposite over adjacent. Tangent of theta equals 4 theta is inverse tangent of 4. This might need to be in degrees.
So the exam will be this easy.
What do we get? Inverse tangent of 4 in degrees?
75.96.
75.96.
Are you just making it look easy?
Now, just like you said, you've had me now. It's almost 2 semesters now.
Yeah. But
Have I let you down before?
no, but my first time having a paper exam for you, so.
Okay, I know. I don't know what to tell you.
He wants to try new things, man.
Make sure your calculator's in degrees, and there it is.
Old school experience.
Right, so calculator at this point is the calculator in degrees. That. Okay. Oh, let me take any questions about this. Triangle, shadow, same angle. Yes?
So the fact that the person's eyes are 6 feet above ground level, that's just there to throw you off?
Yeah, I mean, you could go ahead and put a 6 here, try and figure this distance out, but the angle's the same. The triangles are similar, right? So this is a right angle. These 2 lines are parallel, right? And so, yeah, the angles are the same. Other questions about this? These two angles are parallel because this is a transversal, right? And what angles are these? Yeah, there's the same angle. Do you know the name of them? They're corresponding angles from geometry. Okay. Number 3. All the calculator. Here's the story. So it's heavily calculator based. Right, so first of all, figure out which story it is. Now here, you're going to have to, again, this is the closest one I could find to what was written, so you won't even be given this. So I might as well just go ahead and just scratch this out and write your own. All right, so you got to come up with your own. Read this question, right? See if you can come up with the equations, and then we'll bring the calculator up again to show you how to do this. Oh, this is broken for real? Maybe just the lens. Oh, there we go. There we go. Can we read that? We can read that, right? Should I make it bigger? Packages of 6, 12, and 24. So it looks like X, Y, and Z, right? A store, so 17 packages total. One equation?
X plus Y plus Z.
That's the total number of packages. There's one about money.
$2, 2x plus 3y plus 4z equals 54.
And how many razors?
6, 12,
Right. So there's 6 razors in this package, plus 12 razors in this package, plus 24 in this package, right? Equals 234. Right. That's the system. I'll take any questions about that. Again, for those of us who are going to be listening to this later, we will pause for a moment as someone is going to show us how to put this in the calculator. You will be able to hear it but not see it. It's got this. Let's see if we can go to this thing again. It's supposed to show in a second. It's not showing yet. This one. Okay. It's trying. Yep. Volunteers? Somebody wants to show how to do this? Or just lend me a calculator. Just give me a calculator and I'll do it. Yeah, okay. So, does someone need to see this? Or do we all know how to do this?
I'd like to see first.
Okay, okay, okay. Alright, so then gotta focus just a little bit, right? Is that okay? Bright. How do we turn off the brightness? Oh, this. That doesn't seem like it's going to help at all, right? Yeah, why does it get so bright?
Do you need the light on?
Oh, well, let me see here. You can see that, right?
Mm-hmm.
Roughly.
You can bring down the.
That's up a little bit over.
There you go. You can bring it.
That's good.
Okay, so then we're talking about second matrix, and then we're going to edit this one, put it in A. So second matrix, edit. It looks like this thing, including the column on the other side of the equal sign, is by rows, 3 rows and 4 columns. And then we're putting in the coefficients. Read them off for me. 1, enter, 1, enter, 1, enter, 17. 2, 3, 4, 50, 6, 12, 24, 234, right? Second, quit, just get out of there. And then we want to do reduced row echelon form. Second matrix, for my people, we're going to take linear algebra. Reduced row echelon form is when you get 1s on the diagonal and 0s everywhere else. Reduced row echelon form of that matrix A that we just edited. X is 7, Y is 4, and Z is 6. Okay. Questions there? Okay. We're good? Okay. Who's this? All right, excellent. Our exam, great. 4, solve for x using logs. I think I got enough space right there. We're going to remember some log rules. So we're going to bring all the logs on one side. For you, all the logs will already be on the same side, okay? Again, this was the one that was closest to the one that was going to be given to you, right? So you're going to just bring this on this side, and that equals 2. And here we're going to recall a log rule, and the log rule is recall that log base 4 of A minus log base 4 of B equals the log subtraction turns into division. Subtraction turns into division. Okay. So using this rule, it's called the quotient rule, then you bring the logs together. Log base 4 of x plus 2 over x minus 5 is equal to 2. The subtraction turns into division. Now we just invoke the definition. What's the log? The log is the log's the power. So this means that 4 to this power equals this, and then we can solve for x. 4 to the second power equals x plus 2, over x minus 5. And then we can go ahead and do the algebra. I'll take any questions up until this point. So we bring the logs all on one side, leave the 2 over there, use the log rule to turn the subtraction into division, invoke the definition that the log is the power you need to raise 4 to in order to get this. That allows us to drop the log, and now it's just algebra. 16 equals x plus 2 over x minus 5 or cross multiply. 16 times x minus 5 equals x plus 2. We'll distribute the 16. 16x minus 80 equals x plus 2. Subtract 2. I'll subtract x. So 15x equals 82. X is 82 over 15. Go ahead.
So all you're doing today is final exam prep, that's it?
Yeah.
Okay.
See.
It's gonna be multiple choice on that one.
No, but it's going to be just like this problem, except the log is already going to be on that side.
Alright.
Yeah.
And we're going to do the practice on Pearson, and then in class, we're going to do the exam.
Yeah.
Okay.
You said except the log is going to be on.
Yeah, you don't need to move it.
We won't have.
Yeah, it's already going to be in this form already.
So we're just solving.
You're just solving immediately. Yeah, yeah. But again, this was the one that was closest to the one that you would see. Yeah.
Okay.
So for this one, you had to move it over.
Right.
But yeah.
Yeah.
Questions about this? There's one for solving trig functions. I've also, oh wait, maybe not. So 5 and 6, maybe they're only 9 problems. 5 and 6 I've joined together because it couldn't fit something that was going to happen in this question, right? So I'm going to solve this one, and then I also want to talk about number 6. And number 5 and number 6 actually go together. So let me copy them both over. All right. Okay, great. All right, so we're going to solve for x here. Cosine x plus 2 sine x cosine x. What do they both have in common? A cosine, so we'll factor that out. Okay, so they both have cosine x, so ignore this. They both have cosine x in common. That leaves 1 plus 2 sine x. And oh my goodness, here is where I'm concerned, because now we'll need the circle and we won't have the circle. So sine x, subtract 1 divided by 2. Sine x is negative 1/2, or cosine x is 0. Where's the cosine x equal to 0? Here?
Yep.
What angle is that? Pi over 2. Or here? It is 3 pi over 2. So it's pi over 2, 3 pi over 2. And when is the sine negative 1/2? It's down here somewhere. It's either at the pi over 3s or the pi over 6s.
Can we bring
Can we bring it?
yeah.
7 pi over 7,
Give us an evil
It's
math.
7 pi over
6,
7 pi over 6 or
11 pi.
11 pi over 6. That's
Just
right.
the unit circle, please.
I'm going to have to think about that. 7 pi over 6 or 11 pi over 6. What do you want to happen? You just want, maybe I'll,
Cheat sheet.
oh, there's not going to be a cheat sheet. No, not for these, not as much as I'm revealing right now. But
So,
What about
It's
extra
Just a unit circle.
yeah, so maybe if I just attach it to the final, right? Have it, yeah.
I think it's 7 pi over 6, 11 pi over 6. That will confuse me on the what's called.
You just look at the circle. It's on the circle. You would go on the circle and find out where the y coordinate was negative 1/2. The circle has all these points on it, right? And you're looking for the points because the sign is what's the sign?
Why?
The sign is the y coordinate. So you would look on all the points and find out where the y coordinate is -1/2, and it's these two. Yeah, and if you look at the circle, you'll see, yeah. So I'll probably bring a circle. Go ahead.
Probably could think of another problem, but can there be like multiple like sets of 4s?
What do you mean? So
that's like a set 2. Can there be like a set 4 and you have to pick a set 2?
yeah, that's right. So but here they only wanted the first round. They only wanted 0 to 2 pi.
0 to 2.
So they only want it on the first go around of the circle. They only wanted the ones that are on the unit circle, the first go around.
Okay.
Yeah, so this has infinitely many solutions on the whole row line. So it would be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. And that just means you keep going around the circle. But this here tells you that I only want from 0 to 2 pi. So I wouldn't go past 2 pi.
Okay.
Yeah. I've brought this in with number 5 to let you know that when you factor, you might not always get an answer. Here's the extreme example. Determine whether the statement is true or false. This equation has no solution. Has no solution. Well, why not? When we think something has no solution, let's go ahead and find one and see why it doesn't make any sense.
There's no sine x that's 4.
Right, so sine x equals 4 or cosine x equals -3 are impossible because
They don't exist.
the range of sine, what's the range of sine?
1.
The range is a set. What's the lowest value?
0.
What's the lowest value of sine? What's the y coordinate here? -1 to 1, right? So it could never be 4, right? And so for the same reason, cosine can only go from -1 to 1 because it's the unit circle. So it could be never -3, right? So putting these two together, this means that you're going to do something like this and factor, and one of these is not going to be true. One of these is not going to work. Okay. So you're going to get to a point like this, factor like this, and then one of these two equations will suffer from this problem. Right? So just be on the lookout to not act like you can solve this. And by the way, you'll see this when you do the calculator, right? Because if you do inverse cosine of -3, go ahead and try that. Do inverse cosine of -3.
So we put it's not a statement not true? Or
Yeah, then what that means, you would just cross out one of the answers. Yeah, so like here, you would cross this one out, and then you would say it's just those two.
Which is domain error.
Yeah, it's a domain error. That's exactly right. The calculator would just be like, yo, you can't do that. Yeah.
Is that SC or is that cosine?
Where?
Cosine x plus 3.
Here?
Yeah.
Yes, cosine x plus 3.
Okay.
Right, so here's an example. Let me give you one. So if I said solve this, right? So if I said solve cosine x times cosine x plus 7 equals 0, right? Then this means on the interval 0 to 2 pi, right? So this means that, okay, well, cosine x is equal to 0, or cosine x plus 7 is equal to 0, in which cosine x is equal to -7. But from the argument we just made, that's impossible, and then you would only solve that one. Right. And then you would use the circle to figure out what those values are. Okay, excellent. 7 has to do with the difference quotient. We'll come back to 7 because we'll spend a time just working on the difference quotient. It's a big thing that's important in calculus. So this is just the coordinators for the course. Thought that this was important to cover. Of course, they don't tell anyone until the last minute. So we'll cover that stuff in just a second. So 7, 8, and 9 we'll do later. All right, so exponential stuff. There's the exponential model. A equals 501.5 e to the 0.03t, describes the population in millions T years after 2003. When is this thing going to be 763 million?
I remember that question.
Excellent, yeah. 501. The one on the college algebra one is almost exactly the same for solving that. Here again is where you'll need a calculator again. We'll divide both sides. Here's the game plan. We'll divide both sides by 501. Then we'll do something to both sides, solve for t. Right? So the first thing you'll do is divide by 501.
It's not gonna mess it up that it's 501.5.
Oh, thank you. 0.5. And so it's e to the 0.03t equals 763 over 501.5. What do we do to both sides now?
Right, natural log.
You take the natural log of both sides. So 1 you divide, and then 2 you apply the log to both sides. The natural log of e to the 0.03t equals the natural log of 763 over 501.5. What happens here? They cancel. 0.03t equals this ugly thing. A bit like that. To avoid round off error. And then divide both sides by 0.03. The natural log of 763 over 501.5 divided by 0.03 again in the calculator, going ln 763 slash 501.5 slash 0.03. That's how it gets typed in. The nearest whole number, that's right. What number is that?
14.
14. Answer?
2017.
2017. Questions there on that? 11, heavy calculator question. They're going to give you a function and say, yo, and they won't give you the picture. And they'll say, find the picture yourself. Where are the local maximum and minimum values of this function? So where are the humps? Okay. So I'll put this one in myself. And let's see if Desmos loads fast enough.
We should be able to do that on our calculator also.
Yeah, we should practice now. Let's graph this function. It's 2x cubed plus 3x squared minus 12x. What was it? Plus 3x squared minus 12x plus 8. All right. I'm looking for that. And I'm looking for that. I need both of those, right? I'm looking for both of those. So a local max is a hump that's the biggest value in an area. This is not the absolute maximum because this thing goes up forever. But in some area around -2, that is the highest value. And this is, that 1,1 is a local minimum. In that area, that's the lowest value. Again, it's not the absolute minimum because that function goes down to infinity, obviously because of end behavior. The question is, yeah, so when we're in our calculator, should we show this too?
Yeah.
On the, okay, so we'll put this back up here. Calculator, somebody. Okay, so then we're talking about where was the sweet spot? Right there, roughly. Can we see that? Okay, so then it's y equals, and then read this thing off to me. 2x to the third. Can we see this? 2x to the third plus 3x squared. Minus 8x plus, I'm sorry, minus 12x minus 8 or plus 8?
Plus.
Okay. Plus 8. All right. And then you hit graph. All right. This window is bad. Okay. And so then you should at least go back to the normal window where you want the x values to go from negative 10 to 10. The y values go from negative 10 to 10. That's a better window at least. Press graph again. Right. And so now, yeah, you can see that at least you get an image of what the minimum is. The maximum goes off the screen, which means you'll need to adjust your window again. Okay. So, but if you press trace, you can go down and see roughly what that value is. And the way we're rolling, everything's a nice whole number. So even though the trace looks like it doesn't give you a whole number, basically you can see that it's the 0.11 for the minimum. Right. Now, in order to find the maximum value, you might need to see what you need to change your window. That means you need to change the y values until you can actually see what that value is going to be, right? To get an idea of what that value should be, you could do trace and just follow it until you see it start to come back down. So how high does it? Oh, look. See how it went from 28, well 29, and then it starts coming back down. So you should make your highest y value about 30. That makes sense?
What about the second graph, like when it shows you like all the different?
Oh, that's on the fancy ones. It's not clear. I'm not sure if you can do that on this one. But let's do it. So second, we're going to do second graph. Oh, so here, okay, so what else? So this gives you these values, yes?
Would that be useful?
Yeah, this could tell you too for the same reason, right? So you can see here, that looks like that might be it, right?
How did you get to that again?
Thank you. So it's, I don't know whether you can see here. It says table. So second, and it gives you the table of values. Right? So I think this is a better way to do it actually, because then you can see the values of it, right? So it looks like 1 is the minimum. How do you know this? Because it gets to 8, right? Before 0, it's higher than 8, right? And then, I'm sorry, it's higher than 1, and then after 1, it goes higher again, right? So you could then change your window. Let's change the window, but it looks like it's 28. And then, if we change the window and make the highest y value 30, and then graph it, then your window looks appropriate. And then you can go and trace and go up there and see that it does look like it's -2. And then at -2, you can find that the value is 28. So it's that type of playing around. Yeah.
You just give me
So now let's answer the question. Yeah. So then we've got a point of 1, 1 and -2, 28. That means that the function has a relative maxima or maximum. There's only one maximum. It's at -2 and the actual value is 28. The minimum is at 1 and the value is 1. Just looking straight up. Say it again?
Is that how it's gonna ask it too? Like in a...
Oh no, they're just going to ask for the maximum and minimum value points, and you would put in -2, 28, and 1, 1.
Okay.
Yeah.
Thank you.
Yeah. Yeah. So that's just flat out looking at the graph. And then this is my own personal, yep. Got to be able to solve a triangle. I've talked so much about it. So this one here, got to use the law of sines, maybe some law of cosines, find every side, every angle. Is that big enough?
Yes.
Okay. So then, being super nice, third angle screaming us in the face. 51 plus 42, 93. How much is left? 87 degrees, and now that's 87. And then we can do all sorts of things, okay? So we can find little b by using the law of sines. Oh, why don't we just go ahead and use the law of cosines both times? So b squared is equal to a squared plus c squared. We don't have those, right? So we got to find one of these using the law of sines first. So which angle do we want to use? Let's use the one that's given. The sine of capital A over little a is equal to the sine of capital B over little b. You have all those things except for little b. Capital A is 51. Sine of 51 degrees all over, we'll put your calculators in degrees, all over 106 equals the sine of 42 over little b. Little b is equal to 106, the sine of 42 degrees, all over the sine of 51 degrees. Calculator, what is that?
91.
Say it again?
91.3.
91.3. That fits. 51 is the larger angle, so it's larger than that, right? If you got something more than 106, you know you would have been incorrect. Right, so 91.3, that looks good. And then we can get C from the law of cosines. C squared is equal to a squared plus b squared minus 2ab, the cosine of capital C, and you have every single one of those things.
Or we could have just done the sine again.
Or you can do the law of sines and found, yeah,
And
capital
is
C.
it the same if it's little a over sine big A? Like it's
Yeah, you can do, yes.
solving
Yeah,
it.
my math lab likes that.
Right,
Yeah,
yes,
so-
that's what I was like.
Yeah. So then C is the square root of all those numbers, right? So then it's 105 or 106?
106.
106 plus 91.3 squared minus 2 times 106 times 91.3, the cosine. The capital C was
87.
87 degrees.
106.
Yeah, 106.
Yes, thank you. Any questions on any of that other stuff before we do the difference quotient? Okay, so then the difference quotient is, we're going to use it a lot in calculus, right? So calculus is going to be about the rate of change, and the difference quotient will be helping us measure the rate of change. Okay, so let's go back. So here is the difference quotient. Let's put it here. Here's a definition. The difference quotient for f of x is given by f of x plus h minus f of x all over h. All right. And so when you do this and simplify, the answer should be in terms of x and h. There should be x's and h's all over the place when you do this. Okay. Let's do an example. Let's find the difference quotient for f of x equal to x squared. Okay. Here's an example. It's going to turn out that this is just going to be a bunch of algebra. Okay. I'm going to do three things. There's going to be three steps. Number one, I'm going to find f of x plus h. Number 2, I'm going to subtract f of x plus h and f of x. And as you might expect, the third is that I'm going to then divide all of that by h. All right, those are my 3 steps to do this. Okay, so let me find f of x plus h first. F of x plus h is just whatever you get whenever, instead of x, you put x plus h. And that's x plus h squared. Good, okay? I am going to simplify that. This is still step 1. F of x plus h is x plus h squared, which is x plus h times itself. Will FOIL out. That is x squared plus xh plus xh plus h squared. So that's x squared plus 2xh plus h squared. That's step 1. I'm then going to subtract off f of x. F of x plus h minus f of x is equal to, well, f of x plus h is all that stuff we just got from step 1. X squared plus 2xh plus h squared. And then f of x was just x squared. They cancel. 2xh plus h squared. And the off the record remark is this. Put it in green. After this step, all the terms should have an h. Anything that just has an x should cancel. And then finally, f of x plus h minus f of x all over h is then going to be this, the numerator is going to be the thing from the previous step, all over h. And then the h's divide, and then it's 2x plus h.
How'd you get the x squared?
Thank you. How did I get this x squared here?
Yeah.
Thank you. So it's the stuff we had from the previous step minus the function, but the function was x squared.
Oh, okay.
Yeah. And that's it.
So on number 3, when we put the x of x, blah, 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 yeah, right there where you just had the mouse, why is that one right there? Why didn't we write that in again? Like, why didn't we minus?
Why didn't we write it?
Oh,
like this whole thing here is this whole thing.
We don't need to subtract again.
Oh, you already did it. This whole thing is that whole numerator.
Okay.
Right? We already did the whole thing.
Okay.
Yeah, f of x plus h minus f of x is this.
Okay, I thought it was saying you to minus it.
No, we've already minused it.
Okay.
Yeah, f of x plus h minus f of x is this thing. So this whole numerator, this is the whole numerator.
Mm-hmm.
Yeah. So the only thing we're going to ask you is to do this for a more complicated quadratic. So I'll do one, and then we'll just do them as many as we need to. So let's do 2x squared plus minus 5x plus 4. Let's do the difference quotient for that. Just a ton of algebra. The steps are exactly the same. We'll call this f of x. So we need f of x plus h. We'll then subtract off f of x. And we're simplifying at each step for sure. And then we'll divide. All right, so then f of x plus h, step 1 is 2 times x plus h squared minus 5 times x plus h plus 4. All right, so this is one of these trust me moments, right, where you'll be in calculus and then the professor will say, okay, we need to look at the difference quotient, and you'll go like, ah, I know that, right? And then she will just have you do tons of these, and you'll already be familiar with it. This is equal to 2 times, I'm sorry, is there a question? 2 times, and then again, this is going to be x plus h times itself. That doesn't change, so it's always this, right? Distribute the 5, add the 4, right? And so then we're talking about 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 4. That is step 1. Step 2, when you subtract off f of x, I hinted before that all the things without an h should disappear. That's going to be 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 4, and then it's minus all of f. So then it's minus the original function, which was 2x squared minus 2x squared plus 5x minus 5x plus 4 minus 5x plus 4. I'll write this out carefully. 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 4 minus 2x squared plus 5x minus 4. Oh, I haven't used pink in forever. So then 2x squared, they cancel. I can see now, I can barely see it. They cancel, and then they cancel. So that you're left with 4xh plus 2h squared minus 5h. Is there anything else? And that's it. And then you just cut an h from each one. Xh plus 2h squared minus 5h all over h leaves you with what?
4x plus 2h
minus 5.
Can we just, on the test, can we just put 4h plus 2h minus 5?
Yeah, of course. I'm grading this thing. Yeah, that'll be easy.
So we got some no work.
I say I'm grading. It's like, so we don't have to show any work, right?
Yeah. Good.
No, that's right. So I wanted. So the advantage of me grading is now there's partial credit, right? So my math lab was just marking stuff wrong, and now, right, you can miss a minus sign here. I'm probably still gonna mark the whole thing right.
All right.
Yeah. So not that much of a problem. Okay. This is about how many of these you need to do.
How many of those are on the exam? Just
On the practice?
no, on the actual.
Oh, it is one.
Just one?
This is one, and it's going to be a quadratic like this. Yeah.
Can we look at another practice one? I want to look. I was gonna look at one.
Oh, you want to? Oh, you want to look
I
at?
wanna see can I get it right without doing all that.
Oh yeah. So yeah. Oh, you want to see whether you can just guess it?
Yeah.
Okay.
What if you can just
I am.
No, I'm about to see something. If it's the same. Like,
Yeah. No. It's yeah. There are some patterns. So where is it? Okay. No, it was here. I need to go here.
X plus h.
Here are the
is
other
always
ones.
a pattern.
yeah.
It's 2x squared.
Yeah.
Someone's
X
noticing.
squared plus.
What do you think the answer to number 8 is?
Oh, snap.
We did one like it.
But it's different now because it's got a minus and stuff. I mean, I got a plus that.
Yeah. So you gotta work it out.
So yeah, that was it.
Yeah. So, all right, great. I'm going to end there, and I'm going to be here as long as forever. If you want to see more of these, then you can. Yeah. But yeah, that's it.
So the
Appreciate it.
the final practice exam in back now, it's
It's this. It's open. Take it as often as you want to take
Oh,
it.
it's open on.
Did you use
Right now. Yeah.
Did you use the same numbers or different numbers?
Yeah,
Like,
did you
will it
change the
generate
numbers?
different
It
numbers?
would generate. Yeah. Every time we do it, it'll do something different. Yeah. And again, the ID is in here, so you can see where to practice in the study plan. I'll try and post this when I can.
Tomorrow or next Thursday?
Yeah.